Hi, so I'm Oren from Starkware. We're one of the main teams building Starkware, which is a public layer 2 validity role on top of Ethereum, like OptimisticX role, which is something that you just heard. And I want to share with you some of the thoughts that we're having when we build this network and trying to make it really future-proof. We're also building it using validity proof, so there is a double meaning here in proof. Another angle to it could be is if you're building apps and are considering which chain you want to build them on, some of these are also aspects you should probably also be thinking about.
In here.
Yeah.
Great.
Okay. So briefly I'm going to cover this, a bit about Web3 today. I'll go over several types of network you probably have heard of, how we see it, and then some aspects that we think are important to change that you should consider. Some of it are related to technology infrastructure, and some are the software aspects I hope I'll have time to touch as well. You probably know this adoption curve. What I would like to claim is that blockchain today is still in one of these first two phases. It hasn't really reached mainstream yet. There are not really too many killer apps in blockchain. I think that's probably the thing that's mostly needed right now. Moving forward. Okay. And those are the things that we really need. So again, if any of you are trying to build use cases on top of blockchain, very good. That's the main thing we need. One of the reasons I think we're still there is that the interest is not there, or at least has not been there until recently, mainly in terms of scalability, cost, UX, and these are some of the things that we, amongst others, are trying to solve. So you probably know there are L1s, L2s. Generally speaking, like the major L1s, namely Bitcoin and Ethereum, are very good networks in terms of trust. We probably call them the trust machine when you opened the Devcon 2 days ago, 3 days ago. They're very secure, they're decentralized, credibly neutral, all those nice big words. They also have strong networks around them, a lot of users, a lot of operators, a lot of liquidity already there, securing the network. But they often have some severe limitations, mainly in terms of scale, cost, and UX. Then you have some alternative ones that come along and appear to solve that, the scale, cost, and UX. But typically, when you look at it more closely, they basically do that by sacrificing either scale or decentralization or both. What Layer 2 is trying to do in general, and that's both validity rollups and optimistic rollups, is on that level, on the Layer 2 itself, try and solve the cost, scale, UX issues, but still rely on Layer 1 for security. So Layer 1 is still the trust machine, and Layer 2 is basically outsource that to Layer 1 and do the scale and UX on Layer 2. You probably have seen this before. That's the blockchain trilemma. It basically states that you can't have all three of these things, decentralization, security, and scalability. You have to choose two. The main reason this happens is because, generally speaking, to get security, you have to have each and every full node in the network re-execute all the transactions just to make sure that they're indeed valid. That's how you get security in this decentralized operation. For this to be truly decentralized, you want anybody to be able to run a full node, even on a weak machine. So if you want a weak machine to be able to run all the transactions of the network, you have to sacrifice scalability. The only thing about this is that it's not really true. And the reason it's not really true is that one thing that the people who came up with it left out is they weren't familiar with this new technology that we are using, for instance, but it's not part of Ethereum and Bitcoin, which is called validity proofs, or zero-knowledge proofs often they're called. So what is that? So that's a neat cryptographic construction that was thoroughly researched in academia, but actually well before blockchain. It's not a derivation of blockchain. And it's a set of protocols that basically do the following thing. There are always two sides there. One is the prover, the other is the verifier. Let's say I'm the prover, you're the verifier. What I'm trying to do is I'm trying to convince you that I did some complex operation correctly. So I'm the prover, I do the operation. In addition to the computation that I do some additional work and generate a proof. The format of the proof is defined in the protocol. I send you the proof, you're the verifier. You look at the proof and you decide whether you accept my claim or not. And we want three things from those protocols. One is that we want you want me to be able, if the computation that I did is indeed correct, I should be able to generate a proof that you will accept. The other side of that is that the computation I did is not correct. You want me not to be able to generate a proof that you will accept. In short, this means that I have no way of actually cheating you. If I try and cheat you, you will catch me. And the third, and this is a computational thing, we want the verifier to be inexpensive. So you should be able to run on a very weak machine in very little time, verification to a very complex computation. So I may use a lot more computation power, but you, the verifier, will not need as much. So such protocols exist. The protocol we use specifically is Stark, has some particularly nice properties. So how is that helpful for a layer 2? So without proofs, by the way, that's true for optimistic rollups as well, but without proofs, you have sequencers or miners, validators, different networks call them differently. Those are the nodes that actually take part in the block generation. So there are fewer of those. And then you have all of the nodes, which is a much larger quantity of nodes. In Ethereum, sequencers are maybe thousands, and nodes are probably in the millions. Now, without proofs, all the sequencers need to execute all the transactions for consensus, but also all the full node needs to execute all the transactions just to verify they're correct. And this is basically where proofs actually solve the blockchain trilemma, because proofs do provide you a much simpler way of verifying transactions without the need to re-execute, by just verifying a proof. So with proofs, you still need all the sequencers to execute all transactions, but all other full nodes only need to verify the proofs. They no longer need to execute everything. And since the sequencers can be stronger machines, they actually get paid for what they're doing, they can do a much higher throughput, and all the nodes can still keep track of that because they just verify the transaction. Okay, so this is one part. Another distinction is between public networks and app chains. Recently there are quite a lot of app chains being announced. So I think both of them serve slightly different use cases. So when would you opt to run something on a public chain? I think the main reasons are the ones that I've listed here. One is if composability is important to you, if you want to interact with other contracts that are already there. Another, if you want to leverage the network effects of that network. So if you want to attract the users that are already there, or the liquidity that's already there, or other apps that are already there, then the public chain is good for you. And also it's lowest touch from your perspective. You could just write your app, deploy it on Ethereum or on Starkware on a public chain, and it runs it for you. When may you prefer an app chain? So one general reason for that could be control. If you want to configure the network a bit differently, for instance. Or maybe you want some more privacy than the public network allows you. Or customizability in general. The public network is what it is. Typically you can't change anything there. If you want something different, then maybe you want an app chain of your own. Another reason is you may want to capture the network revenue for yourself. Again, the public network, you basically pay the sequencers or the miners, they get the money. Maybe you want to bring the users, you bring the business, you want to capture it yourself. Maybe you want to subsidize it. Maybe you want to have a different business model there. Maybe you want to have your own token. So you can do all that with an app chain. The third major reason you may want an app chain is for branding or distribution. So if you have a good brand that's going to bring a lot of users, you may want your network to be your own. Okay, so what are some of the things that we think are important in the chain that we think about probably that you should do if you want to build on one? It's not an exhaustive list, but it's some of them, and this is important in different ways, but for both public chains and app chains. So we want usually strong tech, we want security, I'll touch some of them, so we'll see this. Okay, security. So I'm often told by people that nobody really cares about security. I think there's lots of evidence for that out there, not just in these pictures. But I do want to claim that it is important, especially with decentralized systems such as blockchains. And it is true that a lot of people don't really care about security, or at least they don't care about security until they get hacked. And then they care about it a lot. So we are thinking a lot about security. I think if you don't care about security, there are many concessions that you can do, and in some cases you could actually make some. So some things you should consider when looking at security, like how strong is the cryptography this network is running on? Is it important for you that it be quantum, post-quantum secure or not? Is it field proven? Is the code actually running? Is it actually securing lots of liquidity? That does provide some evidence for it being good. This is a network run by an operator or by a set of operators. If something doesn't work, there's some foul play or they're being hacked or something, what's the worst that could happen? What's the damage that they could do? Could they censor transactions? Could they take down the network? Could they steal your money? There are differences here. For instance, in validity rollups, we can't steal your money because there's no way to prove that this is actually valid, but we can censor it. So there are different answers depending on what's important for you. How decentralized is it, if it's important to you? If somebody wants to attack it, how expensive is that? So these are questions that are worth asking if you're looking at a chain or an app chain or technology. But by the way, this is an example. We got a shout out from Vitalik in his opening speech for something that we actually designed 4 years ago because security was important for us. We had an app chain that was running basically DYDX, which is an exchange. They decided to stop operating the chain. But all the users can still get their money out even though they've stopped operating the chain because there's this escape pattern mechanism that we built into day one. So this is an example of something that, like, if you think about it in advance, it solves your problem once you get there. If you haven't, then you have a problem. Okay, throughput is definitely one of the most important things in layer 2s because that's one of the zone that layer 2. Layer 2 is to achieve throughput because layer 1 doesn't have that. So what are the main factors that are basically limiting the throughput in definite networks? So in layer 1s, pretty much all the operations should be some limit. So executing transactions is definitely a strong limit on what you could do. You want all full nodes to do, like all nodes to be able to do that. That's the main reason why they're limiting the throughput. Consensus could also limit some of the throughput because they want it to be very decentralized. So we also this also has a strong effect on how much time you actually have for running transactions. Data, all the data needs to be published to all the nodes there, so that's also limited. The main advantage that validity rollups have on top of that is this idea of proof that I explained before. It has two main effects here. One, and that's the major one, is that execution now, not all nodes need to execute, but only the ones running consensus. As I said before, those are very fewer, and they actually get paid for that, so they can afford running much stronger machines and much stronger clusters, so they can do a lot more scale. Optimistic rollups don't really have any other solution to that other than what their ones offer. So at the end of the day, unless you sacrifice security, you're ending up with the same issue. The second benefit that you have for validity rollups is that you don't necessarily have to publish all the transaction data to layer 1. You could just publish the state diffs for each block or for each group of blocks. So it actually also saves on the amount of data that you need to submit to layer 1, which is also included. So if you compare validity rollups, the main thing you need to check is how efficient they are in terms of execution. That's going to be what is limit throughput. If you compare optimistic rollups, you have to look at that even more strongly, but you also have to look at the data cost because they'll probably also manage. Again, unless you're compromising security. If that's fine for you, then good. If not, then check that as well. These are numbers from StarkNet. As you can see, the throughput is constantly increasing. We're constantly working on that as well. This is not the end of it. And because of the reasons I mentioned before, like these numbers are going to be higher than for other types of numbers. Costs. The cost analysis is pretty similar, but it's not exactly the same. There is an additional feature here, which is the proving, that exists only in validity rollups, and that's, it is indeed only a single node that needs to generate a proof for each and every block, but this is still an additional cost that you don't have in the layer 1s and optimistic rollups. So if you compare validity rollups in terms of cost, you have to look at the execution cost and also at the proving cost. If you compare optimistic rollups, the main two things you need to look is execution costs, which would kick it even more strongly, and also the data costs, which are playing a larger part. These are the costs on StarkNet. As much as I'd like to take credit for this, the big decrease here is not because of something that we did, but rather because of Ethereum's moves to blob. Because when they move to blob, the cost of data on Ethereum actually moved to virtually zero. And that caused this, and all networks are now a lot less expensive. Avenue, which is another strong theme on StarkNet, I don't have the movie here, but they built a paymaster, which is basically a feature saying the user can say extend the transaction, And let somebody else pay for that. That somebody else could be the app. The app wants to subsidize a certain number of transactions, or there could be lots of use cases if you think about it. This also lends to like a Web 2 user look and feel. Because you can do stuff like in video here isn't working, but what it showed is there's a stress test that we did on production basically a couple of weeks ago, where there was this game. Users could actually play this game without installing a wallet, without writing any keys, without signing anything. They just click something, maybe use fingerprint, and then they just play the game. Somebody else actually pays for the transaction. I'll skip some of these because I'm nearly out of time. Some other aspects that are important are not the technological or infrastructure ones, but are maybe some of the software aspects that are also related to the teams and communities of these different teams. And often these things are as important or very important by themselves as well. So when you choose where you want to deploy or which technology you want to use, look at the technology, look at the infrastructure, but also look at the people, the teams, the vision, and the values around that. And that's probably also important. I'll skip this. So for instance, these are some examples from Starkware and from StarkNet. So this is part of our vision, for instance. I probably don't have time for that, so I'll skip to the next one. I'll just mention one thing that we're very actively pushing right now is for StarkNet to become a layer 2, not just on top of Ethereum, but also on top of Bitcoin, which is something that until recently we didn't think was possible, but now we think we have a good way of actually doing that. Bitcoin is also a very good layer 1. It's very secure, and it also has lots of assets on it that currently can't be used for anything except for hodling. Imagine what you could do if you had a layer 2 smart contracts on top of Bitcoin that you could transfer Bitcoin to use. And if you have ideas for applications and you want to build such a layer, then come and talk to us afterwards. This is actually not from Starkware, from the StarkNet Foundation. I won't go over all of them, but also it's probably important if you want to build somewhere that you feel good with the values of that ecosystem. Yeah. And last but not least, look at the people that you have in this ecosystem. Try and sense their energy, what's important to them, what do they value, where would they help. Often this is even more important than like the harder stuff of actual code and capabilities, because at the end of the day, you're going to work with this community. Thank you very much. Many of these here are really thinking of like building something innovative in blockchain. Like I'm going back to where I started with, we're very much in need of killer apps here. So if you're thinking about it, please come and talk to us. There's probably lots of ways